Hi, I'm Sir Akman.
Hi, I'm Miss Mina. Hi, I'm Miss Chesa. Hi, I'm Miss Kaisa.
Okay, let's begin our lesson. Today, we want to learn about atomic absorption spectroscopy or AAS. So, firstly, we need to know what is the spectroscopy first. Spectroscopy is the study of the light interact with matter. Light interact with matter. So, from that, we can know that AAS works due to the light can be absorbed by the matter. Okay, let me show you the example. So this is the sample. So the light can be absorbed to the sample and we can measure the matter. Okay, next, what is the use of the AAS? The use of the AAS is to measure the concentrations of the particular element or the specific element in the sample that to be analyzed. Okay. Next, we want to learn about the type of AAS. Have several types such as flame AAS, hydra AAS, graphite furnace AAS, cold vapor AAS. So the type is differentiated by the atomizer, sensitivity, and the target sample that we want to analyze. Okay, next we will learn about the principle of AAS. The principle will start with the free atom, which is gas, that will generate from the atomizer. So the free atom will absorb the radiation at the specific frequency. Next, AAS will quantify the absorption of the ground state atom, which is in the gas state. Next, the atom will absorb the UV or visible light and transit it to the higher energy level. Let me show you the diagram to more understand. This is the excited state and this is the ground state. So the atom, okay, like this. Next, the analyte concentration, and lastly the analyte concentration will determine from the amount of absorption.
Okay, so next I want to show you the components of the AAS. First, we have the light source, and the most common lamp that we use is hollow cathode lamp. Next, we have flame, which consists the atomizer and also nebulizer. And then we have monochromator, detector, and also reader. So now I want to tell you what is the function of each of these components. First, light source. The function of the light source is it can generate light at wavelength for the element of interest. Okay, next for function of the atomizer is it is the burner for the analysis in the AAS, and for the nebulizer is it changes the solution into the aerosol. Okay, so next for the monochromator is it is the optical instrument that selectively transmit a new range of wavelength of the lights from a spectrum of wavelength. Okay, so for the detector, the process in the detector is it convert light originating from the monochromator into the simplified electrical signal. Okay, so for the last component is the reader, which is it show and read out for the data of the absorbance.
Now we continue to the example on how the AAS measured the lead ion concentration. First of all, we need to know the wavelength that we use for lead. In this table, the lead atom absorbs 217 nanometer. So we will then use the light source, which is hollow cathode lamp that is made of lead, to produce the specific EMR. And as the EMR passes through the flame, which will atomize the water sample, the part of radiation will absorbed by the atom that present in in sample cell. Then it will go to the monochromator that only receive the radiation of 217 nanometer, and the detector will measure the intensity of absorbance. The reader will read out the absorbance value. And now the absorbance value can use to calculate the concentration in lead ion.
Hello everyone, today we're gonna continue our lesson which is about limitation and advantage of AAS. So firstly, we talk about the advantage of AAS. The first advantage of AAS, we know that AAS, it has a high sensitivity and high specification in detecting the metal. This means here, AAS, it still can measure the concentration of metal even it at low concentration because AAS is very sensitive. The second advantage of AAS is AAS is capable to analyze the complex sample. For example, we have a complex sample like biological sample such as urine and blood. So the third advantage of AAS is it requires a low cost. Why AAS require a low cost? This is because it only uses inexpensive consumable such as acetylene and air. Then it also uses a hollow cathode lamp, where we know hollow cathode lamp, it can be used for a long lifespan and can be used many times. So beside the advantage, we also have a limitation of AAS, where we can talk about that AAS cannot be used to analyze nonmetal. For example, we have oxygen, nitrogen, and hydrogen. All of these nonmetal cannot be analyzed through the AAS. Then we also need, for the other limitation is we require careful sample preparation. This is because we want to avoid contamination. If there are contamination in our reading, it's because the result is totally wrong. Okay, so we're gonna continue about the real life application for AAS. First, AAS can be used in environmental analysis. For example, we use it to monitor trace metal in water and soil. Why? It is because it is crucial for us to assess the pollution level, so we can know how the level of pollution in our surrounding. Second, it can use in pharmaceutical industry. This is because, as we know, in the medicine, we have a different type of drug. So it can be used to detect the metal that contaminant in the drug. So from that, we can ensure that medication are safe from the consumption. So in here, I can conclude that you can find another application by yourself.
That's all from us today.